Okay, I broke the video apart into two because YouTube limits the amount of time that the videos can be. So just going over where I left off, 3 times 6 times 18 is 324. 1 times 4 times 1 is 4. I divided them and I get my final answer of 81 grams of H2O. So that's how many grams of H2O are produced if I start with 3 moles of NH3. And I use stoichiometry is this converting from one to the other. And I started with moles and I ended up at grams. So my steps here was moles of NH3, or moles of A. I went to moles of H2O because H2O was my ending result, and I used the coefficients to get there. And then my last step, I went from moles of H2O to grams of H2O, and I used molar mass to get that number for my calculation. Let's do one more example problem. For you. Next one, it says, if you need 16.32 grams of O2 with ammonia, how many grams of NO were produced? So we're going to go ahead and start with 16.32 grams of O2. Remember, it is the given all over 1. Oops, shouldn't write an equal sign there. And we want to go to grams of NO. So looking at the molar map, we're starting in grams, and we have to go all the way to grams. So this is going to be 3 steps. We're going to go from mass of what we begin with to moles of that, from moles of that to moles of B, and from moles of B to mass of B. So I'm going to use the molar map to determine what I have to do next. So I'm going to have 16.32 grams of O2, and I need to go from grams to moles. So remember, the units are going to have to cancel. So this will be grams of O2, and this will be moles of O2. And I have to use the molar mass of O2. Remember, there's 2 oxygens, 2 of them, not just 1. So if 1 oxygen is 16, how much does 2 weigh? 32. And the 32 is going to go on the bottom because the molar mass is 32 grams per mole. That is the definition of molar mass. It's how many grams there are in 1 mole of it. So 32 grams of O2 is on the bottom. That's the molar mass. And 1 mole of O2 is on top. So that is the first step. We are in moles of O2. Now we have to go from moles of O2 into moles of B. In this case, B is NO. So we're going to put moles of O2 on the denominator because they have to cancel. And moles of NO will be the numerator. In this case, remember the balanced chemical equation, I need to know the ratio between oxygen and NO. And here from the coefficients, I'm going to use coefficients from the balanced chemical equation, moles of A to moles of B. In this case, I am going to need moles of NO, which is 4, the coefficient, and O2, the moles are 5. So we're going to have 4 over 5. And that's from the balanced chemical equation. So that's where I got those numbers there, from the balanced chemical equation. Oops, move it down so you can see it. So the next step, I am going to go from moles of NO to grams of NO. So moles of NO is going to be on the bottom because these need to cancel. Remember, everything cancels until the very end. And then on the numerator, I'm going to go ahead and put grams of NO. What is the molar mass of NO? Well, nitrogen plus oxygen. You're going to have to add them together. Nitrogen's 14 on the periodic table, and oxygen is 16. So that is 30 grams per mole. To calculate this, I'm going to multiply all the top numbers. So that is going to be 16.32 times 1 times 4 times 30. And you get a number of 1958.4. Divide that by 1 times 32 times 5 times 1. That's 160. So I take 1958.4 divided by 160, and it's 12.24. The label on that is going to be grams of NO. So I know it looks like a lot, but if you use the molar map, it helps you guide along as you do the problem. Grams of O2 cancels with grams of O2. Moles of O2 cancels with moles of O2. Moles of NO cancels with moles of NO. The only thing we have left is grams of NO, and that's our end result. I'm going to do the next problem, and I'm just going to upload a picture of it because I don't want to take up too much time with the videos. So if you want to go ahead and try the next problem, you're going to start with the same thing. You're going to start with 16.32 grams of oxygen. And instead of going into grams of NO, you're going to go to grams of H2O. So I will post that picture. If you want to go ahead and try to do that right now, you can.